Hello friends, so welcome to another lecture video in our channel. Today we are going to discuss about the origin of quantum mechanics. So from the name of quantum mechanics you all heard about what is quantum mechanics and why quantum mechanics is important and why we are so much curious about doing quantum mechanical calculation, why the quantum mechanics replaced classical mechanics, and these are the questions all everybody should curious about why we are doing quantum mechanics. It has been already 100 years, it is going to be 100 years, because in 2025 it will be perfectly 100 years after the innovation of the discovery of quantum mechanical theory. So because in 1925 Schrodinger and Heisenberg officially declared their equation as the origin of quantum mechanics. So in 2025 it is most probably going to be the 100-year celebration of quantum mechanics. But still there are some quantum mechanical problems which are not yet solved, not yet resolved, and we are very much curious about why we are going to study that quantum mechanics. And though actual reason behind studying quantum mechanics is that the theory developed by quantum mechanics is still yet to resolve, right? So all the theories developed by quantum mechanics is not complete. And what do you mean by complete? In which context we are saying that complete? So in the sense that the theories are complete, but the realization we are going to make is not complete, and we are realizing the mathematics, but we are not yet reached the destination of our final result, right? So these are there are some mysteries, there are various type of difficulties still awaiting to resolve by quantum mechanics. But quantum mechanics is so much beautiful in the calculation point of view compared to classical mechanics, because you are aware of that, you must be curious that why I am talking classical mechanics is so much going to difficult, and why quantum mechanics is replaced classical mechanics. You know that in classical mechanics it is simple to describe a motion of a particle. If I drop my marker pen from a distance, some height h to this height, then you can accurately calculate the velocity of reaching this distance, right? So why I need quantum mechanics? So the main point behind quantum mechanics is that it makes the fundamental aspect of physics, the fundamental theory to describe nature, much more realistic, much more from experimental point of view, which it makes everything sophisticated, so much feasible, so that where classical mechanics fails to explain all these things, right? So here you are know that you all are aware of that quantum mechanics is works in microscopic level, like microscopic in the sense that this is electrons, protons in the atomic level, in the femtometer, nanometer, in this range, 10 to the minus 99 meter, 10 to the minus 6 meter micrometer range. But this aspect of saying that quantum mechanics is microscopic in nature, this is partially correct, not completely wrong, but partially correct, because quantum mechanics works everywhere in galaxy, in this universe, in our surroundings. For example, consider the propagation of sound waves in solids. This works on quantum mechanics. And let's say let's say I hit this marker pen to my hand, it reflects it's bounce back, but it cannot penetrate through my hand, because that principle is Pauli's exclusion principle, which is a quantum mechanical phenomenon, right? So this is a quantum mechanical aspect. This is an observation which we are able to see in our surroundings. So quantum mechanics is everywhere. For example, let's say propagation of sound waves in solids, or conduction of heat in solids. You may aware of the equations developed by Debye and Einstein to know the specific heat in a solid, right? So that is you are know that at high temperature it is specifically constant, that is 3R, and at low temperature it varies as TQ proportional. But how the TQ proportional is coming? That is because of quantum mechanics. You are know about magnetism. In magnetism you study permanent magnets, paramagnets, diamagnets, or ferromagnets. But how these ferromagnets are originating, how they are working, and in which magnetic domains, how magnetic domains are working. So these types of theories we are going to develop by quantum mechanics. So quantum mechanics is everywhere, from conduction of electricity to attract of a magnet by a magnet. So all are quantum mechanical phenomena. So you cannot neglect quantum mechanics without realizing its complete theory. So that's why quantum mechanics is important, but to realize its mathematics purely beautifully, it is too much difficult. But still, if you are able to understand fully its mathematics, then you are able to understand its quantum mechanics. You are all about to understand its fundamental theory, right? So that's all. So it has been already been 100 years, right? So but officially the release of quantum mechanics was in 1925 by famous Schrodinger and Heisenberg. But before that, in late 19th century and early 20th century, quantum mechanics developed, quantum mechanics originated as from the quantum theory of light. Why? Because before that, people believed that light are the electromagnetic waves, as proposed by James Clerk Maxwell in 1864, that light is an electromagnetic wave, right? So why means if light is a wave, then it must show wave behavior. We must say that light is a electromagnetic wave, so light must show electromagnetic wave behavior basically. So to prove that, there was nothing, no experiment have been done during Maxwell's time. So Maxwell believed that his equations are much more strong to develop the to realize the light is an electromagnetic wave. So it has been already 100 years complete to from the birth of quantum mechanics, but quantum mechanics has not already started at 1925, but it started from the early 20th century and the late 19th century. So how it originated and why people believe quantum mechanics is going to be a vast subject and going to be a phenomenal subject which can change the whole world. So there are some experiments have been done which prove that classical mechanics fails and quantum mechanics is arises. Means that classical mechanics is not fails, but classical mechanics could not explain that. Means by the theory of macroscopic domain, as classical mechanics works in macroscopic level, you apply some force and you got some acceleration, that is dp by dt equal to ma. So these type of Newtonian mechanics could not able to explain those experiments. So among those experiments, one experiment was black body radiation. So you might thought that what is black body radiation? What do you mean by black body radiation? So before going to black body radiation, we must know about radiation. So radiations are the electromagnetic waves. Radiations are the energy carried by the electromagnetic waves. So electromagnetic waves, you must be thinking of electromagnetic waves, those satisfied by light. Light is an electromagnetic wave, but how light is an electromagnetic wave was proven, because before the 1925, during Maxwell's era, people are treating electricity, magnetism and light very differently, in a different aspect. Electricity, magnetism is here, light is here, there is no connection between them. But in 1864, the change come. 1864, James Clerk Maxwell come, and he proposed that accelerated charges produce electric and magnetic oscillations, magnetic electric disturbances in the space, which can indefinitely flow through the space. So no one going to believe that argument, because you have no equations, you have no mathematical argument to justify that. Then Maxwell developed his own equation of electricity, magnetism, 4 fundamental equations. Those we are know that one is, I am trying to just summarize those results. Like one is divergence of E equal to rho by epsilon naught, where rho is the charge density, source density. If there is any charge, any source available, then the density per unit volume or per unit area per unit length you can consider, but here we are considering per unit volume, right? So second is divergence of magnetic field is 0. This what this says, monopole does not exist. Means you only get magnetic dipole. Sorry. Then there were two equations which Maxwell realized from the Faraday's famous experiment of electromagnetic induction, right? So Faraday gave the result that a changing magnetic field can produce electric field, or a changing magnetic field can produce current. But so Maxwell know that result. Maxwell was well aware of that result. Maxwell thought that this changing thing can be much more specified if I converse the result. So Maxwell, what Maxwell did? Maxwell changed the aspect of result. It means Faraday says that change of magnetic field produces electric current or electric field. Means changing magnetic field acts as an electric field source. Faraday also changed the aspect. He said that the changing electric field can produce magnetic field. He said that in a symmetric argument, but his mathematics also proved that the changing electric field can produce a magnetic field. So those are two equations, vital equations. So the third one is del cross E equals to minus del E by del T. Fourth one is del cross B equals to mu naught J plus mu naught epsilon naught del E by del T. So these four equations change the whole world and connects the electric field and magnetic field. And how these two equations connected to light, this is a very curious thing, very much simple thing. I will show the mathematics and then you can see properly that these are the electromagnetic waves which can connect it to light. So what to do? So you know the parameters: rho is charge density, epsilon naught is permittivity in free space, and mu naught is permeability in free space, and J is the current density. Okay. So Maxwell thought that if I say these are electromagnetic waves, then wave is propagating through space. Means you created a disturbance. What is waves? Wave is basically disturbance in medium. So you created a disturbance in a uniform medium, in a still medium. There is no disturbance. You created a disturbance, like you throw a stone to a pond. So pond was still, pond was normal, no disturbances, smooth. So you throw a stone. Stone is carrying energy and it transferred its energy to the pond, and the pond get disturbed, and the energy gets shifted by the form of wave from one medium to one point to another point. Medium is same. By the vibration of particles, the energy is transferred from one particle to another particle by the oscillations, right? So here Maxwell considered that if the electric field and magnetic field are electromagnetic wave, are the component of electromagnetic wave, then it must flow through a medium. It must flow through a medium, and there must be a wave equation which satisfy this electric field and magnetic field. And so he derived his wave equation from his mathematics. So I will show that, right? So let's take this third equation. No, first what he did, what did he say that if here Maxwell thought that if my electromagnetic wave is propagating through space, then there must be a region where there is no source, because Maxwell saying that once a electromagnetic wave is created, then it propagates indefinitely through space. Means consider a region where there is no source, right? So if there is no source, electromagnetic wave is propagating through free space. There is no obstruction of this electromagnetic wave. So if I consider a medium, consider a range of medium. Medium is everywhere, and I consider a range in medium. So if I consider that there is no source means there is no charge, there is no current. Means if I consider that rho is equal to 0 and J is equal to 0, then these equation and these equation, these two equations get transformed to what? For no source. नो सोर्स के लिए ये ट्रांसफॉर्म हो जाएगा डेल डॉट ई इक्वल्स टू 0, एंड हियर इट ट्रांसफॉर्म्ड डेल क्रॉस बी इक्वल्स टू mu naught epsilon naught del E by del T, right? Now, using this 4 equation, we are going to develop the wave equation which describes that electric field and magnetic field are electromagnetic waves, are the component of electromagnetic wave. So here I am doing the calculation. So we know from third equation, we know that del cross E equals to minus del E by del T. Del E by del T. Oh, this is del B by del T. Oh, I am really sorry for that. This is del B by del T, sorry. Del B by del T. दोनों तरफ you do the curl product, the cross product, the curl, you have to take curl, right? Del cross E equals to minus del by del T of del cross B, because this curl operator and this time derivative commutes with each other, because this is with respect to space and this is with respect to time. So there is no difference if you take del by del T of del or del of del by del T. अब दोनों same है, two are same, right? So you take this and you apply the identity A cross B cross C equals to back minus cap, right? So what will be here? Del of del dot E minus del dot del of E equals to minus del by del T of del cross B. You put this equation, del cross B equal to mu naught epsilon naught del E by del T. So this is going to be yes, mu naught epsilon naught del E by del T, right? So from here this is going to be 0, because we are considering a region of medium where there is no source. So del dot is 0. So this is Laplacian minus del square of E equals to minus del by del T of mu naught epsilon naught del E by del T. Cancel the minus sign in both sides, then del cross del square E equals to mu naught epsilon naught you can take outside, and this is del square E by del T square, right? So this is looking like a wave equation. So you are already know that wave equation is of the form like a del square. Oh shit, let me change my marker. So you are all know about that del square psi equals to 1 by v square del square psi by del T square. This is the form of wave equation, or this is in 3 dimension. If you consider in 1 dimension, this looks like del d square psi by dx square equals to 1 by v square equal d square psi by dt square, right? Where psi is a form of psi is a function of x and t. Here psi is a form of r and t. R is a radial vector. A radial vector means x, y, z component, 3 component. So this equation looks like a wave equation. So Maxwell from his theory develops that this is a wave equation, this is satisfying a wave equation. Similarly you can do for B, and you can do here first you what to do. So from this equation you take curl in both sides, then here it is 0, then instead of del cross E here you put this minus del V by del T and you get same equation. So here comparing these two equations, like this is our form of wave equation and this is we got. So these two equations if you compare, then 1 by v square is replaced by mu naught epsilon naught. So let me erase this. So 1 by v square is equals to mu naught epsilon naught, implies that v square is equal to mu naught 1 divided by mu naught epsilon naught. V is equal to 1 by under root mu naught epsilon naught. So this expression is equals to approximately equals to the speed of light, which is accurate result is 299,792,458 meter per second, exact result. So what Maxwell did? Maxwell transformed his 4 equation to a wave equation carrying information of electric field and magnetic field. So he did it mathematically, but in his time no one has experimentally proved that these are the electric field and magnetic field coupled together to form an electromagnetic wave which travels in free space with the speed of light. So Maxwell during his lifetime gets no positivity for his result. So he died with a sad manner and कुछ नहीं कर सकते. So then Henrik Hertz came. Henrik Hertz came with his famous experiment. What he actually do? So the experimental setup, I want to demonstrate that. What was his experimental setup? So he generated electromagnetic wave from an AC source, alternating current source, right? So you have a source of current. This is an AC source. Let me draw a schematic diagram, right? Here he put 2 metal balls and these are not connected to each other, and the gap is such that, look, these are the metal balls, right? And this is a source generating electromagnetic wave, generating AC current. So he designed his experiment in such a way that here a spark is going to be occurred when the current reached its peak value, means you have electromagnetic wave propagating through space. So let me consider E, and this is with respect to time, because the electromagnetic wave, if you write like E vector equal to E naught cos omega t, right? Time varying part. So he says that it has a sinusoidal oscillating behavior. So what it is actually showing? So let's say this is 0. So minimum to maximum, then minimum, then minus part of maximum, then to 0, then maximum, then to 0, then minimum, then to 0, then to maximum. So when it reaches the maximum value, the peak value, it is going to produce a spark, right? Spark produce, it will give a spark. So this means that spark can be anywhere. This is an electromagnetic wave. Spark means it can flow everywhere, because there is no restriction that the spark will flow this way, 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 anywhere in 3D space. So what he did, if this spark can this spark can flow through the medium, through free space, then if I design a same experiment but with, instead of this source, I replace it by an emitter, then I can judge current. Because look, so what he did, so he did a similar kind of design to metal balls, and they are spaced in such a way that when there is peak current will be observed, then there will be a deflection in ammeter. There will be an ammeter which will show the current, right? So electromagnetic waves are propagating through medium, through free space, anywhere, right? So when this electromagnetic wave has a peak current value, peak amplitude in the sense this E naught, highest value E naught plus E naught. So we will going to get a result, a current in our ammeter, right? So The thing is, you are sending some signal and you are receiving. This is acting like a sender and this is our detector, receiver, right? So it gives a deflection in our ammeter. This means that electromagnetic waves travels through free space and the spark is an electromagnetic wave. Otherwise we cannot see a spark, we cannot see a current. So current is relating to spark. Spark is a light, because we can see the spark, means this is visible light na. So spark is any kind, means blue light, right? So spark is blue light, means this is light. Light is a wave. Wave means electromagnetic wave. Electromagnetic wave means current. There is electric field and magnetic field. So this experiment is demonstrated by Hertz, Heinrich Hertz, German scientist, German physicist. So he developed this experiment, this setup, and showed that light is an electromagnetic wave which I can detect as a current in my emitter. So this experiment was designed by Hertz and very much important, right? So from then light is an electromagnetic wave, it was fully confirmed, right? But if light is an electromagnetic wave, it must show some wave characteristics. Wave characteristics, what do you mean by wave characteristics? Wave characteristics means we have the wave has wavelength, the light must have wavelength, the electromagnetic waves must have wavelength, means, and if it has wavelength then it must have frequency, and we know that electromagnetic wave has a broad frequency range from radio connection, radio wave to our X-ray, gamma ray, right? So and light must show superposition principle. In superposition principle, what do we see? That two waves coming towards each other mix up to get a resultant wave, which can be created by the constructive and destructive interference. So superposition means you observe two properties, interference and diffraction. So if it will show interference experiment, then there must be some experiment to show interference pattern. So then W. Young come with his double slit experiment. So what in double slit experiment he observed? Let's see. So Young's double slit experiment is such that you have one slit and then you have two slit. The thickness of slit must be in the order of wavelength of the light, whichever light you are going to act as a source, right? So this is the, let's say this is a source of light, right? So light coming here and it gets diffracted, means light get bent to two sources, and this is a primary source, this is a secondary source. You have studied in our what is this theory? It is wave theory of light, right? So here it acts like this source, this light acts as a primary source to this slit and gets as a secondary source, and here it also gets out at secondary source. Then he give a screen. Light is, you don't think that this is only two ways. Light can come anywhere, but here, anywhere light is coming. But for the sake of simplicity, consider that light is coming only two way, right? So light is going to this point, and then it is passing out as a secondary source. So light is going in this way. Mix up with this light. This light is also going and mix up with this light. This light is also coming and mix up with this light. If these two waves, if there are basically simply two waves. If these two waves of light get mixed with constructive interference, means the phase angle, the relative phase between them is same. Means constructive in the sense, if I diagrammatically show you, this is a constructive interference. because these are same phase constructive interference. Constructive, oh, spelling is mistake, constructive, oh shit, constructive. And if the phases between them is perpendicular 90 degree, then there must be a problem. Yes, yes, this is this way. So this its peak can completely cancels its purely negative value. This is its most negative value. This is its positive value. This results in a very low amplitude wave. This is a destructive interference, which results in dark fringe. This results in bright fringe. So he observed in screen. What he observed? He observed this is a dark fringe. This is a dark fringe. Between them is bright fringe. Then this is a dark fringe. This is a dark fringe. Between this is a bright fringe. Dark, dark, bright. For the sake of simplicity, so he used a monochromatic source of light, and here he used a single slit to distribute two lights which have same frequency, because if you have not same frequency they cannot completely interfere with each other. So here the two lights are mixing with each other, and the interference pattern we are observing. So in this manner, light is a wave which fully confirmed, and light is an electromagnetic wave, not a wave but electromagnetic wave, and it shows wave characteristics. It is fully confirmed. So then the experiment come black body radiation, and what is black body radiation we are going to study in next class. So till then, thank you, bye bye. Hello friends, so welcome to another lecture video in our channel. So today we are going to discuss about the origin of quantum mechanics. So from the name of quantum mechanics, you all heard about what is quantum mechanics and why quantum mechanics is important, and why we are so much curious about doing quantum mechanical calculation, why the quantum mechanics replaced classical mechanics. And these are the questions everybody should curious about, why we are doing quantum mechanics. So it has been already 100 years, it is going to be 100 years, because in 2025 it will be perfectly 100 years after the innovation of the discovery of quantum mechanical theory. So because in 1925 Schrodinger and Heisenberg officially declared their equation as the origin of quantum mechanics. So in 2025 it is most probably going to be the 100-year celebration of quantum mechanics. But still there are some quantum mechanical problems which are not yet solved, not yet resolved, and we are very much curious about why we are going to study that quantum mechanics. And though